Here we go. And I'm going to write it down. So this is 13.4, day 3, putting it together. So over here, I'd like you to write y equals a sine b, the quantity x minus h plus k. K is the up-down, and we call it a vertical shift. And you'll see that I abbreviate that VS, vertical shift. The H is the left-right. And we call that a phase shift. And I do abbreviate that PS. So just some vocabulary here. Again, y equals 2 sine x plus 3 is what we're going to graph today. The absolute value of A is your amplitude. The B helps you find the period. The period's 360 over B. So you already have that written in the previous day's notes. So K is called the vertical shift, VS. H is a phase shift, left-right. Remember, H does the opposite of what you think. Get some paper. I have extra up here if you need it. All right, so here we go. Can you guys please put your cell phones away? Okay, right now we're taking notes. Put the cell phones away. Step 1, you want to graph. And we're going to graph y equals 2 sine x. What we wrote down yesterday in our notes was you graph y equals a sine bx. So in this case, that's y equals 2 sine x. The amplitude is 2. The period is 360 divided by b, so that's 360. So we're going to make 4 ticks to the right and call it the period length. Please label as a minimum every other tick. You don't have to label every tick because then that's kind of scrunching. But you're going to go 4 ticks to the right, call the 4th tick mark 360 degrees. Then the second tick is half of that. And that's going to be really important when we get to the tangent graph. My amplitude is 2, so I'm going to go up 2, down 2. But I'd like to do some forward mental thinking. If I look at the actual graph I want to do, what are we going to do in the second part? Up 3. So let's go ahead and just kind of extend our grid up 3. That's just forward thinking. The first one that I graph is going to be y equals 2 sine x. And we know how to graph this one. Where does the sine curve start? 0, 0. And then a is positive, so I go up 1. And you guys, as I've been looking at homework, I'm a little disappointed in a few of them. You need to make sure that you're plotting points. I have people who are just making these waves, and that's not an acceptable sine curve. That you have to have specific points, and we know them. So our first graph is going to be dashed. You continue the pattern on the left. We're going down to -2, 0, up to 2, and back to 0. So make sure, and you guys, these are not pointy. These are not V's. They're rounded curves. Okay, nice rounded curves. So you start with y equals a sine bx. And then step 2, I have a vertical shift. So I'm going to abbreviate it VS. And I'm going to write up 3. And we practiced the up and down and the left and right yesterday, but we didn't do it with amplitude period changes. We just kept it sine x every time. So now we're going to take our current graph and literally take every point, that's going to go up 3. And at the first tick and comma 2, I'm going to go up 3. Up 3. Now if I'm down at -2, that's going to take me up to +1. And then I'm going to make this one solid. If you can follow the pattern on the left, follow the pattern on the left. If you can't quite do that, then literally keep moving the dots up 3 points. Let's also talk, I think I forgot to do this yesterday, about domain and range, because I ask you that frequently. I'm asking you to graph 2 full periods, one to the right of the y-axis and 1 period length to the left of the y-axis. Domain, though, it oscillates forever to the right and forever to the left. My range are the y values. So in my final graph, which is solid, what's the lowest y value? 1. Okay, so the lowest is going to be bracket 1, comma, and what's the highest y value? Not 4, 5. And now I want you to stop and think a moment. Do you remember when we first learned about amplitude? If I draw halfway through this, okay, if I draw halfway through it, you go up 2 and down 2. There's your amplitude. You get it? And from 1 to 5 is 4 units, and amplitude is half the difference. Half of 4 is 2. So it verifies my amplitude. Yeah.
So like when I was drawing the 2 things, I got confused by the range.
Yes, because the red one is like, it's just getting me started. The solid one is the final graph. It's y equals 2 sine x plus 3. So I only want the domain and range of the final graph. Yes. All right, so domain, range, I got my vertical shift, amplitude, period. Cool. All right, let's try this one. I have a total of 6 problems we're going to do today. 4 are graphs, and 2 of them are writing equations. Say that again. Because they are included. Yes, they touched 1 and they touched 5 on that last one. All right, so example 2. We want to graph y equals -3 sine the quantity x minus 90. Step 1. You want to graph y equals -3 sine x. My amplitude is not a -3. Amplitude is the absolute value of A. The period length is 360. Does everybody understand amplitude is absolute value of A? Period is 360 divided by the B value. B is what's in front of X. So I'm going to make 4 ticks to the right and call it the period length. It is not always 180. Or excuse me, 100 or 360. It's not always that. It varies from problem to problem. Okay, amplitude is 3. So I'm going to go up 3, down 3. Let's do some forward mental thinking. X minus 90, how is that going to shift the graph?
Right.
Right, how many? 90 degrees. 1 tick is 90, so I'm going to make 1 extra tick, okay? So we're going to do y equals -3 sine x. Yeah.
Would the A value change, like, would it go down?
Yes, okay. Sine starts at 0, 0, but because A is negative, instead of going up to 3, you go down to -3. Good catch. If the A value is negative, and I want you to think about this, this is like a reflection over the x-axis. Okay, so if I went up to 3 and you stuck a negative, it reflects it Just like our parabolas, when you had x squared, a negative x squared, it flipped it upside down. So instead of going up to 3, it flips it down. So let's make our main 5 points. We'll make it dashed. And then if you continue the pattern on the left, because we want to get a full period to the left and a full period to the right. Then step 2, we have a phase shift. Okay, phase shift is the right left, and it's right 90 degrees. So right 90 degrees, you have to figure out how many ticks or what part of a tick is this. Since each tick is 90, that means I'm just going to take every tick and move it right 1. And then make that one solid. And then it's really neat when you look at it because you can see the graph is physically moved to the right. So my domain is negative infinity to infinity. Because the graph oscillates forever and ever to the right, forever and ever to the left. So the domain is negative infinity to infinity. My range are y values. So this one goes down to negative 3 and up to 3. When you talk about domain and range, interval notation is the smallest value on the left, largest value on the right. All right, how are we doing with this? Is this making some sense? So I'm not doing anything new today, but putting everything together. No, that's a great question. And somebody wrote me a note when I looked at homework yesterday. Just tell me which one is the final. Tell me what color you need to somehow put this one's the final one. Yeah, give me a little legend or key. Okay, y equals 1/2 sine the quantity x plus 60 degrees plus 4. No, it is not. It's 360 divided by b. So step 1, you're going to graph y equals 1/2 sine x. So my amplitude is 1/2. The period length, there's nothing in front of the x, so it is 360. Ooh, this one's going to be interesting. I'm going to make 4 ticks to the right. That's 360. Now, if I make 1 tick, and I know I'm going to be going to a half, let's do 2 forward mental thinking things. I'm going to eventually do a vertical shift up 4. So let's go 1, 2, 3, 4 up. And then this is going to go left 60. But 1 tick is 90. So what I'm going to do is I'm just going to make 1 full tick to the left. And if you're going to go left 60, instead of left a tick, what portion of a tick are you going to go? It's not half, because 45 degrees would be half. What's 60 over 90?
2/3.
2/3. Okay, 60 over 90. I'm going to go 2/3 a tick left. Okay, so that's something to think about. All right, so let's just do our 1/2 sine x. So it starts at 0, 0, and you're going to go half up. This is like itty bitty. And then you go half down, half up. Step 2 is I have a vertical shift up 4, and I have a phase shift left 60 degrees. All right, so this one I've got two things I've got to shift. So you can start wherever you want to start. I usually start at the origin. So if I'm at 0, 0, and I go up 4, 1, 2, 3, 4. Whoops, I didn't want it up there. Sorry. My bad. That is not a dot there. Just copies. Okay, so let me try it again. So when you go up 4, then I need to do left 2/3. I forgot about the left 60 degrees. So then here, I'm going to go up 4. So now I'm at 4 1/2, but left 2/3. So I'm going to go up 4, left 2/3. Up 4. Now this is down at -1/2. So it's going to go 3 1/2 and left 2/3. Up 4. And left 2/3. So this was kind of tricky. And if you see the pattern, like this one is going to need to go, and you just do it any which way you want. So I'm going to go up 4, 1, 2, 3, 4, left 2/3. Up 4, left 2/3. Up 4, left 2/3. Up 4, left 2/3. So like it should be following the same path. My domain is -infinity to infinity. But does anybody want to tackle the range? Between what two numbers is this oscillating between? Grace, what do you think?
3 1/2.
Yeah.
And 4 1/2.
Yeah, and let's think about that. If my amplitude is 1/2, do you see that distance is 1, half of 1 is 1/2. Oh, that makes sense. Okay, that makes sense. So vertical shift, VS, stands for your up-down. Phase shift, don't let that new vocabulary bother you. PS, phase shift is the left-right. So 60 degrees, that was not a whole tick, it wasn't a half a tick, it was 2/3. And I'm just going to expect it to be a little bit more than a half, okay? Not perfection, but definitely more than a half.
Do we have to say like vertical shift? And then,
Yes, because like on homework, on the next couple of homeworks, I'm going to be saying, tell me the vertical shift phase shift. So I want you to put it, with that proper name. All right, let's try this one. So now I'm putting everything together. So far, all of the period lengths were 360, and they're not always 360. So I'm going to show you why here. So if you want to graph y equals 5 sine the quantity, 3 times the quantity, x minus 30 degrees, close, close, minus 2. Yep, so 2 steps. The first step is y equals 5 sine 3x. So when I've been saying y equals a sine bx, if there's a number in front of the x, we include it in step 1. The amplitude is 5, and my period length, finally, is not 360. It's 360 divided by 3, which is 120 degrees. So I'm going to make 4 ticks to the right and call it 120. amplitude is 5. So I go up 5, down 5. But then let's do that forward mental thinking. I have a -2 at the end, which means it's going to get shifted down 2 units. So I'm going to add 2 ticks below. And then right 30 degrees. Ooh, what's 1 tick? 30 degrees. So I'm going to add 1 tick to the right. So we're going to first graph y equals 5 sine 3x. So I start at 0, 0. I go up to 5, 0. Be careful, you're only going down 5. Whoops, put something in the wrong spot here. Let me go back. I got a little distracted here. Let me try this again. Okay, so 0, 0, up 5. Here's 0. Then I go to -5 and 0. So this one really is a big stretch. And then continue the pattern. Step 2, my phase shift is right 30 degrees. And my vertical shift is down 2. So now when you're ready, if I want to move right 30 degrees, that's right 1 tick. Oh, now I know where my problem is. I'm like, why does that look so weird over there? That's because that was my other tick. At least I caught it. There. So I'm like, that looks weird. Alright, so I'm going to take every point and go right 1 tick, down 2. 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 So if I continue the pattern, right 1, down 2. Right 1, down 2. Right 1, down 2. Right 1, down 2. So my domain is -infinity to infinity. Anybody want to try the range? -7. 3. So 3, right? Because I'm going from 5 down 2. So it would be the 3.
When you're writing the range,
Yes.
you write like smallest.
Yes, the range. Even though like you might see the positive number first or something, in interval notation, it's just saying these are allowable, the smallest possibility to the largest. All right. Example 5, we're not going to graph. Okay, we're not going to graph, but I want to see if we can write the equation of the sine curve with amplitude 2 and period 180 degrees. So we have worked on this before, so let's see if we can't piece it together. I'll give you a moment to jot down the problem. is y equals a sine bx. A is your amplitude. And they'll say something like if A is a reflection, okay, if they say A is a sine is a reflection, then your A is going to be negative. To get B, the period length is 360 over B. And this is 180. So B has to be 2. So this is going to be y equals 2 sine 2x. All right, questions on that one? We're going to do one more. Get it? Oops, I forgot to write it. Okay, write the equation of the sine curve with amplitude 1.5 and period length 270 degrees. So A is 1.5. The period length is 360 over B. Now, I don't know about you, but off the top of my head, I can't think of a number that if I divide 360 by it, that it's going to give me 270. So there's a good reason why we did what we did in Chapter 8. It was solving fractional equations. So what you need to do is you multiply both sides by b, and that's going to give me 270b equals 360. Okay, we're going to clear the fraction. So I multiply both sides by b, and then to solve for b, I divide by 270. Well, I can cancel out the zeros, and 9 goes into 36 4 times. 9 goes into 37 3 times. So b is 4/3. So this will be y equals 1.5 sine 4/3 x.
Is that ever gonna say like that moves like up to or like to the left 90 degrees so that you have to